Okay, class, I want you to design a wind tunnel, a really powerful wind tunnel, one that's capable of producing wind speeds of 150 miles an hour with laminar flow. The test section must have a cross-sectional area of 1 square foot. Sensors need to accurately measure lift and drag with minimal crosstalk. And the whole thing needs to be modular so it can be broken down and move throughout the school. And while a commercial wind tunnel with these specs would cost over $50,000, you only have a budget of $5,000. To which my class asked, "What's a wind tunnel?" To which I said, "I'm not going to answer those types of questions." Students are capable of amazing things if given the opportunity. This was my first class of my first day teaching high school. The administration at Freeport High was brave enough to let this novice teach a class called Advanced Project Design, in which the entire year was dedicated to solving one single problem: to build a wind tunnel. The class consisted of only 9 students, ranging from freshmen to seniors. And my role was not of a teacher of content, but rather an advisor that helped the students create a framework from which they could succeed. I want to highlight 3 aspects of this project: independent learning, project management, and open-ended problem solving. Clearly, I was not going to be any help in actual designing of the wind tunnel. Instead, students had to comb through a number of graduate papers to find out information relating to theory, wind tunnel design, and calculations. They later had to research technical data to make sense of the complex charts and graphs used in sizing and speccing the equipment, such as the fan and motors. Students had complete control of the project. They used project management tools like Gantt charts, which create timelines for scheduling events and identifying key deadlines. They then implemented a system called Scrum, which breaks down large, complex tasks into small, manageable chunks for which each student is responsible. In this way, students took ownership of the project. Now, moving a large volume of air in a controlled manner is a difficult and complex open-ended problem. To find a solution, students had to work through the engineering design method. After defining the problem, they then created a number of computer models, which they then iterated using flow analysis to optimize the tunnel shape. Open-ended problem solving also requires learning through failure. So when I noticed the students had made a small 1/8 inch error in the dimensions of their contraction cone, the most complex component of the tunnel, I asked if they had double-checked all their measurements, but said nothing else. The day before spring break, the students got together to assemble the contraction cone, only to find out the pieces didn't quite line up. They had 2 choices: hack what they had, or come in over spring break and build the entire thing from scratch. Every single student elected to come in over spring break and build it correctly. There are no more measurement errors after that. The end result is this beautiful wind tunnel. Not only has it reached speeds of 150 miles an hour, but it has achieved speeds greater than 230 miles an hour, which we believe may be the fastest in the state. But more importantly, if you ask any of these students, they'll point to this project as the highlight of their high school experience. Students are capable of amazing things if given the opportunity. Before becoming a teacher, I was an advanced robotics engineer at Boston Dynamics. There, I helped design and build a number of robots, including Rise, the wall-climbing robot, Rex, Little Dog, and of course, Big Dog. Working at Boston Dynamics is the dream job of any engineer. It's a wonderful company filled with brilliant engineers where you get to create cutting-edge technology. And while I loved it, I had also been interested in teaching and education. In my spare time, I helped out on student projects and began to reflect upon what were the skills that made me a successful engineer. I began to realize that I relied heavily on a number of skills that were not part of mainstream high school curriculum. Namely, open-ended problem solving, independent learning, and project management. As an engineer, 90% of my job was finding creative solutions to open-ended problems. Open-ended problems are problems that have many possible solutions. There's more than one way to make a robot climb a wall, just like there's more than one way to advertise a pair of running shoes. Yet, unlike the real world, most high school problems only have one correct answer. Think of any math test or science lab you've ever taken. Open-ended problems are challenging and take a great deal of time. Solving them requires working through a designed method, defining the problem, developing a number of creative solutions through models and prototypes, and then iterating those models to achieve an optimized final solution. The key to this is iteration, which requires learning through failure. But when was the last time you had a teacher say, "I want you to fail at this"? Good creative design requires failure. If you don't push your model to failure, then you don't know the limits of your design solution. And it is in seeing your model fail that forces you to reach deeper and come out with a more creative solution. This is just as true for stand-up comedians as it is for engineers. At Boston Dynamics, I was constantly learning new skills and information. Technology is changing so rapidly that whatever you learn today may be obsolete by tomorrow. Therefore, it is more important to learn how to learn than any particular set of skills. Lastly, I had to manage my time and resources effectively. We had objectives to meet with limited time and money, and managing them was crucial to the success of any project. Moreover, these robots are a result of a team effort. I had to collaborate, not only with other mechanical, electrical, and software engineers at Boston Dynamics, but also with teams at Stanford, CMU, UPenn, MIT, and others. No one person is responsible for the creation of these amazing robots. So, where did I get these skills? As a kid, I was constantly working on projects, like designing and building snowshoes, or boats, or a flywheel-powered go-kart. These projects were often unsuccessful. I went through 9 prototypes of snowshoes before finally coming up with a design that worked. And my flywheel-powered go-kart only went about 200 feet before collapsing in on itself. But it was in doing these projects that I gained the skills that would later make me an effective engineer. So, why are these skills not emphasized in high school? Right now, there's so much focus on content that there's little time to develop these essential skills. As the world has gotten more and more complex, we have responded by teaching more and more material. No algebra class would be complete unless you get through the chapter on factoring radicals. But this teaching model leaves no time for true exploration of open-ended problem solving. Learning from failure, optimization, design iteration. These things take time, a lot of time. And it's hard to imagine any class dedicating 2 months or more to a single problem. But this is exactly what I think we should be doing. It is only by committing ample time for students to explore long-term, real-world projects that we allow them to develop these important skills. Moreover, the internet has made almost all content available to us at our fingertips. We should therefore be reducing our emphasis on content to make room for these self-directed projects. Why are these self-directed projects so effective? Career analyst Dan Pink was right on in defining the elements of motivation as autonomy, mastery, and purpose. But think of your high school experience. Did you have the autonomy to choose what to learn and how to learn it? Were you able to master any skill or subject? Did your work have a direct impact on your life or community? Students learn best when they are engaged, when they are intrinsically motivated. Yet most high school students seem to be driven by extrinsic motivations, like getting a good grade or not getting expelled. Now, this obviously does not tell the full story. Much of the skill and content taught in math, science, social studies, and English is vital. Moreover, many students are deeply engaged in open-ended problem solving through their art classes, electives, and extracurricular activities. But these creative opportunities seem to be pushed to the side in mainstream high schools. Rather, they should be emphasized and integrated into the curriculum. Long-term, self-directed projects are an excellent tool since they both motivate students and teach them those essential skills. It was at Boston Dynamics, as I helped students on their extracurricular projects, that I began to realize the importance of these projects to students' learning and motivation. So, I decided to put my ideas into practice. I left Boston Dynamics, moved back to Maine, and started teaching. I built a curriculum that would engage students through long-term, real-world projects. And it was through projects like the wind tunnel that students not only learned those key project skills, but also gained autonomy, mastery, and purpose. In my second year at the high school, I had 4 students design and build a gas-fired kiln for the art department. Here again, design iteration was key to the success. The problem with a kiln is how to move the hot air evenly so there are not hot and cold spots. As you can see, there's a dramatic improvement between Design 1 and Design 14. In my boat design class, I give students the last 4 months to design any boat of their choosing. Max Jennings designed and then meticulously refined this rowboat. 2 months later, he built it. Not only is this gorgeous, but it rows as well as any boat I have ever been in. In fact, he and a friend then the next summer built 2 more, which they are currently selling. Given the success of these student projects, I began to wonder, would it be possible to create an entire school where every student was given ample time to work on his or her own project? And that's exactly what we've done at Baxter Academy. Every class, not only are the classes project-based, but every Friday, the entire day is dedicated to self-directed student projects. Students have the autonomy to choose and manage their year-long project, but must show that it is both innovative and ethical. This autonomy leads to passionate engagement, in-depth learning, and mastery. And therefore, these projects go beyond the good work that is being done at many new expeditionary high schools. Baxter Academy has only been open for 4 months with 130 9th and 10th graders. But the diversity and creativity of these projects is amazing. And while we are a STEM high school, we recognize that these projects are complex and draw upon many fields. The humanities are vital to the success of these projects. We are also now seeing students' performance in classwork improve as a direct result of their project work. And, as in the real world, students must raise the necessary project funds beyond a minimal stipend. Here's just a sample of some of the projects going on right now. We have teams of students creating video games, like this one, Milo. Others are creating iPhone apps. A group of students has started their own radio station, while another group is studying the ethnomusicology of southern Maine. Ever wonder what a balloon filled with confetti looks like the instant that it pops? Well, the high-speed photography crew has just overcome the latency issues with their microcontroller and is starting to produce some amazing photographs. This is a mock-up of a full-body virtual reality simulator to work with the Oculus Rift. These students are building a cedar strip kayak. We have students painting murals, and we have 2 students who, over the next 4 years, will design and build a set of super efficient tiny houses. There are students designing wind turbines, and there are students designing quilts. Lastly, I want to highlight one endeavor that really embodies the power of these student projects. Travis, Nick, Joseph, and Liam are juniors and seniors at Freeport High. Together, they've taken a combined 16 classes from me. Last summer, they wanted to go beyond the classroom. They formed the company Limbeck Engineering LLC with the goal of producing a submersible robot that had greater capabilities than commercially available robots, but at half the price. To define their requirements, they met with oceanographers and marine biologists at Gulf of Maine Research Institute, Bigelow Labs, and Woods Hole Oceanographic Institute. After that, they started designing various subsystems. Given the large scope of the project, they outsourced some of the work to my current students at Baxter. The Baxter students have mainly been working on the propulsion system, and here's their first model. Now, I know this doesn't look like any thrusters you've ever seen before, but what this theoretical model tells us is the power requirements for the robot based on various criteria. Limbeck Engineering then uses this data to size and spec the motors, propellers, and batteries to match the capabilities of the robot with the demands of the scientists. Here's their current prototype model. This robot should be capable of a number of things that currently available submersible robots do not have, such as 5 degrees of freedom, an expandable payload bay, stereoscopic vision, and the ability to remotely station keep while wirelessly streaming back live video and data. So, what do these projects mean for Baxter students? It means they'll be prepared to face the unknown challenges of tomorrow. They'll be creative problem solvers. Baxter students will see failure as a tool to learn from rather than something to be afraid of. They'll thrive on unfamiliar and challenging problems. They'll be able to manage their time and resources effectively. Baxter students will love learning and independently seek out new skills and information. They'll be able to collaborate, and they'll be engaged in their communities. They may not have learned how to factor radicals, but they'll be able to figure that out on their own. Thank you very much.